Starting with the name of Allah, the most gracious and the most merciful. Today we are going to present our FIP. My name is Rahel Ahmad and my group mate name is Muhammad Handla. The title of our project is Rover Familiarity Application. So we will discuss it one by one. So there are outlines of our presentation. First we will go to introduce you our FIP, then motivation and problem statement, solution, literature review, aims and objectives, methodology, results and discussion, conclusion, future recommendations. So I am going to introduce you our FIP. Our FIP is Rover Familiarity Application. What is Rover Familiarity Application? It is a type of rover which can move on hilly three-dimensional terrain and subjected to strong physical interaction constant. So if the terrain is three-dimensional and there are obstacles and ups and downs in the terrain, so it can easily face it. Second is which can also face small 90-degree angle obstacle equal in height to radius of wheels. It can face small 90-degree angle obstacles, the obstacle which has 90-degree and is equal in height to radius of wheels. If the height of the obstacle is equal to the radius of the wheels which we have used in our rover, so it can easily face it. And third one is which control remotely in range of approximately 1 kilometer. Since we use remote control for our rover, and the remote control will work in approximately 1 kilometer, which can carry load more than 1 kg. So what is the motivation behind this project? It is duty of engineers to play their role in every aspect of life. No doubt militant agencies play a vital role for protection of the country. Military protect our country, our motherland, and protect us from the enemy. So it is, being an engineer, it is our duty to help them in new technologies. The second motivation behind this is it is said that modern problems require modern solutions. Modern solution can be implemented by using modern technology. So what is the problem statement? A nation or country need advanced technology for military applications. As the word going to advancement, military also need its technology, advanced technology and new technology. Our military need rovers and machinery which can face many hurdles and obstacles for carrying goods or weapons between checkpoints remotely. Since our military have their bases and camps in areas which are three-dimensional and have many obstacles, so they have problems in transferring or carrying goods or weapons between checkpoints remotely. It is dangerous for military to patrol in risky or border areas and also bomb blasting in desired location. Since it is the duty of military to patrol in risky areas or border areas. And if they want to blast bomb in desired location, it is very risky and dangerous for them. Also, it is very hard and risky for a soldier to carry bomb detector in hands. Carrying bomb detector in hand is risky because it can be blasted anytime. What is the solution of the above problem? Our solution is to design an electromechanical electronic rover system which helps soldiers in combat by decreasing exposure to bodily harm, transporting explosive, tracking and engaging enemy targets on uneven terrain. So we have studied literature review for our project. We have studied different papers. The first paper is written by Singh P.K. Jain. The title of the page is the research paper is design and concept of rocker bogie suspension for planetary rover prototype. So if you see in the picture, it is a design of rocker bogie system, rover prototype. It has 6 wheels and each have a suspension system in case of if one wheel is an obstacle. So all other 5 wheels will remain on the ground to power push the rover. So it have maximum power to face the obstacle. Similarly, the other is dark rocker bogie optimization design. Design is same as above. There is no difference. There is, if we can see, there is free pivot joints. With the help of these free pivot joints, the front before the obstacle, the front will try to climb the obstacle, and the back 4 wheels push the front wheels to climb the obstacle. Similarly, if they take grip and climb the obstacle, it help the back wheels to pull to climb the obstacle. And the third research paper is design of stair climbing rocker bogie mechanism. It is also a rocker bogie which can climb stairs. In this paper, we have studied that if the obstacle height is greater than the radius or diameter of the wheel, then it can easily climb it. We have also studied about the control, how to control our rover. We have studied the paper there. He used central controller which can be controlled through Wi-Fi, Bluetooth, GPS, and can use front camera and rear camera, gyroscope, and motion detector, also servo controller. But we have rejected the control. We have central controller in our project. We have used remote control due to the security and hacking problems. And we have not used front camera, rear cameras, accelerometer, gyroscope because the project become too heavy. And it will be used for future recommendation. And we have motion controller. We have motor controller 293D used for to control our motors. Now, what are aims and objectives of our project? Developing a rover which can face many hurdles in their way, which can face 90-degree angle, small obstacles, as already told before. Design of electrical and rechargeable rover. So our rover is electrical and rechargeable, which can be controlled remotely. We will use remote control to control our the rover, which can carry load of more than 1 kg, which can be used for bomb detection and bomb blasting in desired area. So we will start our methodology, mechanical design, selection. First we will I want to present you the mechanical system of our project. Then I will go to electrical as mentioned in the slide. So first we've gone through the selection of the design. We have studied different research papers of both and different designs of rover, both bell type and wheel type, and then select 6-wheel rovers. There are reasons behind the selection of the 6-wheel rovers because it has more advantages. Then we developed SolidWorks design. We have developed a design on SolidWorks, and it is shown in the slide with the dimensions. Cutting design using shopboard. We have shopboard in our fab lab, so we cut the model SolidWorks design to shopboard. Changes in the design dimensions because we face many problems in dimensions. Then we print again and again and cut the design again and again. Then we assemble at last. So there is a picture of cutting and assembly of a design. The design is cutting to shopboard. We have in our Fab Lab in Sector IBM. So now I'm going to told you about the electrical system component selection. First, we go have component selection, which type of motors we want to use, and wheels to, and similarly control testing of components. Then we test our components that it will work finely. Interfacing Arduino with transmitter and receiver. Code compilation and debugging, assembling, testing, troubleshoot, and then we final our electrical system. As you can see in the slide, there is circuit diagram of a project, both with SFI6 receiver. So it is for only for two motors. The circuit diagram is only for two motors. We will use single Arduino and then four motors. Due to the rating of the motors, we need single motor driver for every motor. We can't use one motor driver for two or four motor drivers. It is a video of fabrication. This is a shopboard machine. We have cut our design. It is a customized design. Here we have worked on the motor controlling using fly sky receiver and transmitter. Through Arduino. You can clearly see here that how the motor can be controlled using fly sky. To reverse the motor, forward the motor, one will go reverse and the other will go forward to for taking directions. Here we are going to assemble our prototype, and here we're testing the prototype. This was a video of a fabrication of our project. So the main topic of our project, result and discussions, that how it works finally or not. So we test our design on different terrains, different obstacles, different surfaces. I will discuss you one by one. Test on different surfaces. We have taken test on different surfaces: flat surface, uneven surface, grassy surface, sandy surface. On flat surface, the rover can easily go and have no problem. On uneven surface, it can easily go to uneven surface while facing different obstacles, ups and downs in the terrain or surface. Also, we have checked our rover in grassy surface. Since the rover has no axles between the pair of the wheels, so it can easily go through grassy surface. The grass can easily pass through it. And then sandy surface. In sandy surface, the rover have some problem because the width of the wheels is very long, small, approximately of 1.5 inches. So although it work fine in sandy surface. Then we have tested on type of obstacle. Since we have different types of obstacles, single side obstacle, it means that if an obstacle face only one wheel or one side wheels, and double side obstacle if the obstacle face both side wheels at a time. So what is the reaction of the rover? And then we taken other results. Climbing means that if it climb a slopey area, down climbing 90-degree obstacles. So you can see the results in our video. It is a flat surface and the rover can easily go through the surface. Sorry if I go back and I will try to increase the width of the video. Okay, it is a flat surface. The rover can easily go through flat surface. It is a uneven and sandy surface and grassy surface. If we can see, the rover can easily go through that surface because it has more flexible. It can easily climb the slope. It is approximately 30 to 35-degree slope. Here we have 90-degree obstacle. If you can see, this is a 90-degree obstacle and face both wheels at a time, both front wheels at a time, and then back wheels step by step. So if we can see that the rover can easily climb the obstacle. But here the rover need more power. It can discharge battery. So it is uneven sandy surface. The rover can go through uneven sandy surface. Obviously, it will need more power and will consume battery to go in sandy surface because due to the low width of the wheels. So there were the results of our project. So some other results we have taken because in case of failure of one motor or wheel, it can go easily. In case one wheel fail or one motor become fail, so it can go easily and climb obstacles. So here we are going to conclude our presentation. Majority of our project's objectives and goals were met. The design is very efficient for rough terrain. Due to its flexibility, it is very efficient for rough terrain. It has no extra springs or extra suspension system. Both the sides can independently traverse different obstacles. If the type of obstacle or a height of obstacle is different on both sides, so it can easily transverse. 6 wheels keep the rover powered in case of failure in one wheel or motor. As I already told you before, so it is 6 wheels. In case of failure of one wheel or motor, you can keep the rover powered. Rover doesn't oscillate too much because it has no extra spring or suspension system. No, since the project is not complete, although it is good but not completed, it needs more modification. It can't be used for military application for now. It needs more upgradation to use it for military application. It needs to use metal body design which have low weight, for example, aluminum. Adoption of updated technology. We will use updated technology, for example, cameras, gyro sensors, implementing camera system for live coverage to make it self-stabilizing, depot carrying material with remote control, add bomb detecting device on it. It has self-bomb detecting device. There are the references of the paper we have studied. Thank you.